Hello, I'm Michael Munroe. Welcome to Part 3 of Elma Electronics' Introduction to OpenVPX. In this episode, we'll discuss backplane apertures, how they are defined, and their importance to the OpenVPX standard. Backplane apertures represent a significant addition to the VITA 65.0 and 65.1 standards. Other important additions include the host and SOSA work on VITA 46.11 chassis managers and the announcement by TE of a new 25 gigabit per second capable backplane connector that is backward compatible to the current VPX backplane connector. In my opinion, though, the introduction of VITA 67.3 represents the most significant advance because VITA 67.3 backplane apertures allow new configurations of coaxial and optical connections to pass signals through the VPX backplane. Apertures are opening in VPX backplane slots that enable the use of blind mate RF and optical connectors. The modules requiring apertures are defined in the VITA 66 and 67 standards, and the type of aperture is defined within the individual VITA 65.0 slot profiles. The importance of these backplane connector modules is that they can be installed and replaced by the end user, and the VITA 67.3 backplane apertures can support modules with different arrangements of RF and optical connectors for each aperture size. In this example of a VITA 67.3 implementation, it can be seen that the VITA 67.3 RF module is supporting edge launch SM/PM contacts off of 3 mezzanine levels. The spacing of these mezzanines will be specific to a given daughter card design. VITA 67.3 allows custom configurations of contacts to support such designs. This is an example of 2 different types of contacts that can be used on VITA 67.3 apertures. In the upper right-hand corner, you can see 4 cable assemblies that would be snapped into the top row. Below that, you see edge launch contacts that might be used to launch directly from mezzanine and or the base board. As I stated earlier, the contact row spacing can be unique to the customer's application. The purpose of these apertures is to support blind mate RF or fiber ribbons that pass signals through the backplane. This allows rigid, semi-rigid, and flexible coaxial cables to be installed behind the backplane rather than draped across the front of plug-in modules as was done in the past. This improves system reliability and allows more precise control of these RF signals. This 6U plug-in module example shows a VITA 67.3 connector module in the J3 and J6 locations. The illustration on the right is from the VITA 67.3 standard, and it shows a 3U slot profile with VITA 67.3C module located in place of the J2 connector. This table the table shown defines the locations of each possible aperture location within a 3U or 6U slot. An X dimension is given for each possible backplane location and is in relation to the center of the upper alignment key. The location on the plug-in modules needs to be derived by the designer from the backplane location. The VITA 67.3 document also shows the locations for half-size modules. Similar location charts can be found for the necessary aperture locations in VITA 67.1, 67.2, 66.1, 66.4, and in the draft for VITA 66.5. VITA 67.3 defines the required mounting holes for each size aperture. The reference point and cutout dimensions are given for each aperture size. The location, type of contact, and the coordinates for the contact locations within the module envelope must be defined by the original module designer and are recorded in a VITA 65.1 table. For each new VITA 67.3 module configuration, a table is added to VITA 65.1. So here's an example from VITA 65.1 of how the contact type and its position coordinates are shown for each defined VITA 67.3 module. VITA 67.3 also defines the numbering scheme for any number of contacts. This chart defines the X, Y coordinates and type of contact within a given VITA 67.3 connector module and is found in VITA 67.1. Is found in VITA 65.1. There is a separate chart for every new VITA 67.3 module. It is important to note that these locations are only given for the backplane module. The module designer determines these locations based on his daughter card contact requirements. Thereafter, designers using a defined VITA 67.3 module must derive the daughter card locations from the XY coordinates given for the backplane contact locations shown in the VITA 65.1 table. The colorful table below shows how to decode a slot profile name. You can see all the many options for slot profile features, and this is based on the VITA 65.0 section 1.3.3.1. This video episode is concerned with the letter names for apertures in the section of the table that reads Connector Aperture Pattern. The VITA 65.0 assigns letter names for each different aperture size. These letter names are used in slot profile names to indicate the type of aperture required for that slot profile. The number of options shown in this table can result in a very lengthy profile name, such as the one shown at the top right of this slide as an example. A corresponding slot profile illustration is shown below that slot profile name. Notice that the slot profile name ends in a decimal section number within VITA 65.0. Each slot profile has its own detailed section where signal names, clock terminations, pipes, apertures are all defined with rules and permissions. The name of the slot profile corresponds to the features in the slot profile from top to bottom of the illustration. Notice that this slot profile name example ends with 14.6.11, which is the section where all the details of this particular slot profile are defined. This particular slot profile contains one Type H aperture cutout. If you look at the chart, it will show that the H indicates that an H aperture supports a VITA 67.3C module. If it had been a J, it would be supporting a 67.3D half-size module. Because the slot profile name can now become so very lengthy, engineers often refer simply to the relevant VITA 65.0 section, such as 14.6.11, because it's easier to type and speak than the entire slot profile name. 4 sets of slot profile images are illustrated here. The slot profile illustration is shown next to a photographic image of an actual backplane slot. Working from left to right, the first pair of images shows a VITA 14.8.7 slot profile, which contains a half-size VITA 67.3D aperture. Notice you'll see that the photo shows that that position is filled with an MT optical module, a half-size module. The second and third pair of images are both for slot profiles containing full-size VITA 67.3C apertures. In these two examples, the VITA 67.3C replaces the J2 connector in a 3U slot profile. The first one, the 14.2.11 slot profile, contains a full-size 67.3C aperture, which the photo shows to be populated with a combo connector module containing 4 SMPM coaxial contacts as well as an MT optical ribbon ferrule. The second, VITA 14.9.1, also contains a 67.3C aperture. However, the photo shows that in this case it's populated with a module containing 11 SMPM coaxial contacts arranged in 3 rows. The last pair of images is for a VITA 14.8.8 slot profile, which contains a VITA 67.3E aperture, which is also referred to as full plus half because of the connector space it occupies. The photo shows the aperture populated with a module containing 12 SM-PM coaxial contacts. It is important to remember that each slot profile aperture can support many different connector modules fitting that aperture size. Each connector module defines a different arrangement of contacts. The 3U 12-slot CMOS backplane is shown here. 7 of the 12 slots contain VITA 67.3 apertures. These apertures are found in slots 2, 4, 5, 7, 8, 9, and 11. Slot 3 is for a 67.3D half-size aperture. Slots 4, 5, 7, 8, and 9 all have 67.3C apertures, and slot 11 has a VITA 67.3E aperture. There is extensive documentation covering all the VSO standards related to OpenVPX. It began with VITA 46.0, which was further defined in VITA 65.0 and 65.1. This slide shows 47 different VITA standards as well as some Defense Department standards, which are all based on the VPX architecture. The VPX architecture continues to grow, and more documents will be written as required. The subject that we have covered in this episode is from the documents highlighted in yellow. This page can be thought of as a reading list for VPX designers and implementers. I hope that you found this tutorial on OpenVPX Apertures informative. Visit elma.com for more information, including links to other VPX tutorials. Thank you for joining me. I'm Michael Munroe with Elma Electronics.